In the year 2000, the first non-prism total station was released. Because a reflective prism was not necessary, there was the expectation the application range of this technology would extend to one being able to take measurements safely and efficiently in previously hard-to-reach and hazardous areas, such as high places and slopes. However, even after a decade had passed, the standard method for measurements remained unchanged. Existing traditional total stations have lasers which pass through the crosshairs. However, they are unable to measure the tips of lightning rods or the corners of buildings. If there are no marks or distinguishing features on the target object, such as a telephone pole, it is impossible to line up the center. In order to meet this need, the Baum was invented. The Baum has concentric circles drawn on the crosshairs of its reticle. The Baum's calibration is set at regular intervals. For example, at calibration 1, an object 10 meters away is marked as 10 millimeters. At calibration 2, the same object will be marked as 20 millimeters. By replacing crosshairs with the Baum, conducting offset surveys of structures becomes a possibility. Similarly, the coordinates of the pointed ends of lightning rods and round cylindrical objects are now obtainable. Additionally, measurements of spherical reference points used by 3D laser scanners can now be taken. Now, with the advent of 3D laser scanners which make use of spheres as target objects, we can expect to see many new applications to be developed in the future. This technology has been put to use on large-scale heavy machinery used in pile construction sites. Until now, measurements of piles have been made by the use of two transit instruments from two different directions. Using this method, it is necessary to reposition the transit instruments each time the pile is struck. However, with the Baum, now only one total station is needed on site. Additionally, because the data of slopes can also be acquired, it is now possible to measure inclined piles. Even more, data can now be digitally recorded and managed. Now, for a further explanation of the pile driver navigation system and workflow. Set up the Baum station. Select the pile data previously recorded. Next, measure two positional points on the heavy machinery. After that, take the measurements of the pile. The measurement data can then be sent wirelessly to a PDA and viewed using the easy-to-understand interface. As demonstrated from the operator's view of the screen display, the positional relation of the pile and the Baum station are shown as being on a level surface. The pile's slope can be measured from either the front or the side of the pile. The numerical value of to what degree the angle and distance should be adjusted is shown. The depth of the pile toe tip and the position of the pile head is displayed. The pile driver navigation system enables easily understandable and highly precise pile construction, all from navigation done from the operator's point of view. Measurement data of all sorts can be stored digitally, which is useful for keeping construction records. Replace those crosshairs with the Baum. Through this small change, the efficiency of total stations is raised to their fullest.